Hi everyone, this is a demo about bpfland. bpfland is a Linux scheduler based on SCADExt. SCADExt is a Linux kernel technology that allows you to implement custom schedulers in BPF and load them at runtime in a pluggable way. bpfland is actually implemented in part in C code that is then translated into BPF and another part in Rust. In this demo, I want to show you one of the recent features that I added, that is topology awareness. And to show you this, I'm actually using a quite complex architecture. So you can see some details here. There's SMT enabled, but not on all cores. It's an hybrid architecture, so there are P cores and E cores, meaning performance cores and energy efficient cores, and there are multiple levels of caches. Some caches are shared among some cores, others are not. So yeah, and you can see like the lower, they have different frequencies, and the lower CPUs are those that are more suitable for performance, and the higher numbers are more suitable for energy efficiency. So if you, let's say you want to save power, you want to extend your battery life, you may want to select these cores on the right. If you want more performance, you may want to select the cores on the left. And as you can see here, like if you select all of them evenly, you may get inconsistent performance. And as you can see here, so this is the default Linux scheduler. It's trying to spread tasks among all the available cores, and in terms of FPS, it's not bad, it's pretty consistent, but sometimes the FPS drops down. And that's probably because it's, this application, it's a WebGL application, can run either on the P cores or on the E cores. So it's using different CPUs that are running at different speed and have different capabilities. Now let's try to start bpfland with the auto performance profile. The auto performance profile will try to auto-detect the best cores. And as you can see here, like the FPS is a little more consistent now. In terms of power consumption, it's pretty much the same. And I'm actually using a few cores, not all of them. And these are the cores that have the highest frequency. So it's a subset of the P cores with turbo boost enabled. And this allows to achieve like a really consistent FPS performance using pretty much the same power. And this happens because I'm running on battery power. As you can see here, the power consumption even dropped from 5 watts to like below 5 a little bit. And so I'm using less power and I'm having a much more consistent FPS. Now let's say that I want to save power because I'm running on battery, and I go here in the little battery widget, and I select the powersave energy profile. bpfland will detect that automatically, and it will try to adjust the primary scheduling domain to use only E cores in this case. And as you can see here, the FPS dropped significantly, but also the power consumption as well, because we went from 5 watts to almost like 2.2. So in this way, I can actually save a lot of power, and I can definitely extend my battery life. Now let's say that I want more performance, and I'm going here and selecting the performance profile. Now what happens is that bpfland will readjust the primary scheduling domain to give more priority to the P cores. And as you can see here, like the FPS is super steady now. Of course, I'm using a lot more power, so I'm really draining my battery. But that's fine. I mean, it's what I want. I want performance now. That's probably like a setup for gaming, let's say. Now let's go back to the balance mode here. And again, bpfland will adjust the scheduling domain to use only a few cores, still providing a pretty stable and consistent FPS. Of course, if I'm running like more tasks and if I'm trying to overload the system, the task can overflow on the other cores, but as long as I'm not overcommitting the system, bpfland will try to select like the minimum subset of cores to provide good performance and without using too much power. Now let's try another thing. Let's say, so I'm still running on the balanced power profile, and let's try to plug the AC power. Okay, now it's plugged, and as soon as bpfland detects that, we should see also, yes, okay, the battery widget up here changed the little icon. So now bpfland readjusted the primary scheduling domain again to use all the P cores, because now I'm just running on AC power. I care a little less about using power. And as you can see, like the FPS is really stable. Power consumption is not as crazy as using the performance profile, still higher than the balance profile, like before when I was running in battery power. But the FPS is really consistent now. And if I unplug the power, everything should go back again to the little subset of cores, using only the subset of P cores that have turbo boost enabled. And this is nice because, you know, we're using less CPUs, so many of them can go idle and they can save power. And using those that have a higher frequency allows them to actually go idle faster. So we can also save a little bit of power and at the same time give a higher FPS here. Okay, that's all for now. Thank you for watching. Bye.